Friends, very good morning to everyone. Today we are going to discuss about the limit test for sulfates. As we know, the limit tests we carry out to know whether the impurities present in the given inorganic substance is within the limit. Limit test for sulfates is carried out to know the sulfates which are present as impurities in the inorganic substance, is it within the limit or not. In general, in the limit test, we take a reagent, and this reagent will make it to react with the trace amount of impurities that are present in the given substance. And this reagent, what we add, reacts with the trace amount of impurities, and it gives the product which is either insoluble, that gives a precipitate, or gives the product with a color. The intensity of color of the product and the intensity of the precipitate that is formed, it depends upon the amount of inorganic impurities present. This coloration or the precipitation, we are comparing with the standard solution which we add the standard amount of that impurity. If this impurity, thus precipitate or the opalescence or the coloration of the product what is produced is lesser than that of the standard solution, then it passes the test. In case of limit test for sulfates, we are using the barium chloride as a reagent. This barium chloride reacts with the soluble sulfate ions, and they two react together to give rise to barium sulfate, which is insoluble in water. Insoluble barium sulfate. This reaction is carried out in the presence of an acetic acid. Overall, the principle behind the limit test for sulfates is the reaction between the barium chloride and the soluble sulfate in presence of acetic acid to give insoluble barium sulfate, which produces an opalescence. The intensity of the opalescence produced is compared with that of the standard solution in which the standard amount of barium sulfate is added. If it the intensity of precipitation in this test sample is lesser than that of the standard sample, then it passes the limit test. This test is designed to know and control the sulfate impurities present in the inorganic substance. Right. As I said, the opalescence produced in the test solution is compared with that of the opalescence produced in the standard sulfate solution, which contains the known amount of sulfate impurities. Here, the sulfate ions SO4 2 minus, which is present in the inorganic substance as an impurity, reacts with the barium chloride BaCl2. Barium ion is cation, chloride ions are anions. Sulfate ions are anions. The anions and cations, they are having opposite charges. That's why the sulfate ions, which is excess in electrons, share its electrons with barium ions. When this share its electrons, the chloride ion gets removed, and the product is formed in the presence of acetic acid, which gives barium sulfate, which is insoluble in water, and chloride ions gets removed. The amount of barium sulfide formed depends upon the amount of sulfate ions that is present in the inorganic substance. And why we are using dilute acetic acid? This is because of the fact that the barium sulfate which is formed, first of all, it is insoluble in this dilute acetic acid. In other words, it increases the insolubility or it decreases the solubility of barium sulfate in water, and it helps in producing good appellescence or turbidity. As these sulfate ions are present in the small amounts as impurity, that precipitation what it occurs, it gives turbidity. In this reaction, we add small amount of potassium sulfate in both the test and the standard Nestle cylinder. Why this is added? This potassium sulfate what is added, it increases the sensitivity of the reaction. The potassium sulfate which is present, it acts as a seed point and it helps in complete precipitation of the barium sulfate, and it also increases the rate of formation of barium sulfate. Rate, because of the increasing rate of formation, rapidly it forms the barium sulfate. It acts as a seed point for precipitation of barium sulfate. Ethanol is used in this reaction along with this potassium sulfate and dilute acetic acid. Why this should be used? If at all ethanol is not used, there will be supersaturation, and because of supersaturation, there will be the lumps of precipitate that is formed. And because of these lumps, the turbidity will not be uniform. If we add ethanol, this ethanol which we add prevents the supersaturation. And because of this prevention of supersaturation, it gives uniform turbidity. That's why we add ethanol. We add acetic acid to completely precipitate the barium sulfate and to give turbidity. Potassium sulfate we add in little amount to increase the sensitivity of the reaction, which makes the precipitation complete, and also it makes it to occur rapidly. Ethanol is used to prevent supersaturation and to form uniform turbidity. In examination, a question may be asked like ethanol is added in the limit test for sulfates. Give reason. We have to write that ethanol added prevents the supercellulose saturation and it produces uniform turbidity. It may be asked as a short answer question. The question may be asked similarly, what is the use of adding dilute acetic acid in the limit test for sulfates? We have to write that the acetic acid which is added makes the precipitate of barium sulfate insoluble in water, and that's why it aids in the formation of opalescence or turbidity. Similarly, a question may be asked as a short answer question. The potassium sulfate is added in the limit test for sulfates. Give reason or explain. You have to say that the potassium sulfate added in the limits test of sulfates increases the sensitivity of the reaction, and it helps in rapid and complete precipitation of the barium sulfate by acting as a seeding agent. And each and every reagent or the added will have a role to play in the test. That's why without any role, we are not adding any other reagent. Barium chloride is the major reagent which reacts sulfate ions and gives barium sulfate. Other substances like acetic acid or potassium sulfate or ethanol, what we add, it intensifies the formation of barium sulfate. That is the purpose of adding other reagent. Now we can appreciate the addition of the reagents which act as an aid in the precipitation of the barium sulfate. In the earlier pharmacopoeias, barium sulfate reagent containing barium sulfate and ethanol was used instead of ethanolic sulfate standard solution. We are adding potassium sulfate, right? Here barium sulfate was used. Here potassium sulfate has been used. In earlier pharmacopoeias, instead of acetic acid, hydrochloric acid was used. Hydrochloric acid is comparably a harsh reagent than that of acetic acid, and that's why in the other recent pharmacopoeias, hydrochloric acid has been replaced by acetic acid. By this replacement of HCl by acetic acid did not affected the barium sulfate formation and the sensitivity of the test. That's why we are using acetic acid instead of hydrochloric acid. That is why avoiding this mineral acid and replacing with environmental friendly acetic acid so that the test become green or eco-friendly. We go for eco-friendly reaction because the solvents or the reagents what we use should not affect the environment or the atmosphere around us. That's why we are going for more and more eco-friendly reactants and reagents. The procedure followed for the limit test of sulfate is as follows. We take two Nessler cylinder. In one Nessler cylinder, we prepare the test solution. In another Nessler cylinder, we prepare the standard solution. And we compare the opalescence produced in the test Nessler cylinder and with that of the standard solution taken Nessler cylinder. In both the test and the standard solution, we take 1 ml of 25% weight by volume solution of barium chloride in both the test and the standard Nessler cylinder. Barium chloride is the reagent which reacts with the sulfate ions, which is present as an impurity in the given inorganic or organic substance. Then we add 1.5 ml of ethanolic sulfate standard solution. This ethanolic sulfate standard solution is having 10 parts per million of sulfate ions. As we know, why this should be added? It increases the sensitivity of the reaction. We added barium chloride for 1 ml followed by 1.5 ml of ethanolic sulfate standard solution. We mix well and allow it to stand for 1 minute. Then to the test solution, we add 15 ml solution of specified quantity of the inorganic or organic substance which is dissolved in water. And each and every substance what we use may not be soluble in water. In that case, the pharmacopoeia prescribes how this 15 ml solution is prepared. As per that, we have to prepare and add 15 ml of solution of the specified quantity of substance in the water. In standard solution, instead of this specified substance, we add 15 ml of standard sulfate solution, which is containing 10 parts per million of sulfate ion. To this above mixture, we add 0.15 ml of 5 molar acetic acid in both the test and the standard solution. Why this acetic acid is added? To increase the sensitivity of the reaction so that it gives complete precipitation. After that, we make up the volume with water to 50 ml. We use distilled water because the water what we use, the tap water if we use, it also contains sulfate ions which also precipitates. That's why you should always use distilled water when we carry out the limit test. We have to stir the solution after making up the volume to 50 ml mark and allow with the help of a glass rod and allow it to stand for 5 minutes. 5 minutes is required for the complete formation of precipitation. Then we are comparing the opalescence produced in the test solution with the opalescence produced in the standard solution. It passes the test when the opalescence produced is lesser than that of the standard solution. This is how the limit test is carried out. And if I see the test solution, the opalescence produced, and the test solution and the standard solution opalescence produced. In this, the opalescence produced in the test solution is lesser than that of the standard solution. That's why it indicates that the sulfate ions present in the given substance is within the limit. Now let us look into the preparation of the various reagents used in the limit test for sulfate. The reagents how we prepare. 25% barium chloride we prepare. 25% weight by volume. Means weight. How much amount of weight is present in the prescribed volume? Percent means 100. Percentage of barium chloride present in the given solution is 25%. 25 grams of barium chloride I take and dissolve in 100 ml of water. I'll get 25% weight by volume barium chloride solution. How to prepare 5 molar acetic acid? Any molarity, X molar of this compound can be prepared by diluting 57X. X indicates the molarity required. Acetic acid molecular weight is 60 grams. And when we this way it is as it is present in the liquid form, we take the density into consideration. 60 grams of acetic acid is equivalent to 57 ml. That's why if I take 57 into 5 molar I need, that's a 57 into 5 ml or 60 into 5 ml. 6 5s are 30. 300 grams of acetic acid I dissolve in 1000 ml of water, I will get 5 molar acetic acid. If I take glacial acetic acid that is having dissolved in the water, glacial acetic acid I have to take 57 into 5. That is 285 ml of glacial acetic acid I take and dilute or make up to 1000 ml with water. I get 5 molar acetic acid. Ethanolic sulfate standard solution we use, which contains 10 parts per million of sulfate ions. We take one volume of 0.181% weight by volume solution of potassium sulfate prepared in 30% ethanol and make up the volume to 100 ml with ethanol, 30% ethanol, then it gives standard ethanolic sulfate solution. Here 0.181% of weight by volume I will prepare. I'll take 181 mg of potassium sulfate and dissolve in 30% ethanol. I'll get 0.181% weight by volume solution of potassium sulfate. I take one volume of this prepared solution and make up the volume to 100 ml with 30% ethanol. I'll get ethanolic standard sulfate solution which is having 10 parts per million of sulfate ions. Sulfate standard solution is also prepared in the similar way of that ethanolic sulfate standard solution. Here we use 30% ethanol. Instead of that, we use totally water. We have to take one volume of 0.181% weight by volume solution of potassium sulfate dissolved in distilled water and make up the volume to 100 volumes with the same water. These are the ways of preparing the reagents, and these reagents were used in the limit test for sulfate. This is how the limit test for sulfate has been carried out. In the next presentation, we will be dealing with the limit tests of other impurities. Till then, have a nice day. Thank you.